Howdy doody. All right. After a couple days of IQR, measure of variation, time to move on to guess what? Another measure of variation. So we looked at the IQR. We looked at just plain old range, so interquartile range and just range. Those are measures of variation. And the last one we're going to look at in sixth grade is real crazy. This one's called the MAD, not the emotion, MAD, which stands for mean absolute deviation. It's a little crazy, but you'll be able to do this, I think, really well after a bit of practice, and I hope I can explain it in a way that helps you understand. So here we go. Mean absolute deviation is a statistic that measures the distance that data values are from the mean, from the average of the set of data. So what this looks at is it looks at you take a set of data and you find the mean, the average. And then you say, how far is every number that's in the data set? How far is each number from the mean, from that target number? That's what mean absolute deviation measures. It measures how far every number is from the mean. And the best way to make sense of this is just to go through an example. So I like to break things into steps, and that's what I'm going to do for you here. Feel free to pause, rewind, do what you need to do, but we're going to be working with this example data set that I just made up, okay? I made up these numbers here. These are just randomly generated 1, 2, 3, 4, 5, 6, 7, 8 numbers. I've got a 1, 3 2s, 3 4s, and a 5. And we are going to find the MAD, the mean absolute deviation of this set of data. So step 1, if I want to find out how far each number is from the mean, I have to find the mean first. So our first step is going to be find the mean. And I think most of you can recall, to find the mean, you simply add each number up and then divide. In this case, I'm going to divide by 8 because there are 8 numbers in the set of data. So 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5, all of that divided by 8. So according to my calculations, the sum of these numbers is 24, which when you divide that by 8 is 3. Cool. So I found the average, I found the mean. The mean of this data set is 3. Now, what we're going to be doing is we're going to be finding the deviations. We're going to be finding how far is each number from the mean. So how far is 1 from 3? How far is 2 from 3? How far is 2 from 3? And so on and so forth. To find the distance, my tip for you is to organize your data. You can use any method you prefer. I like using a table just because it helps me to make sure I've used all the numbers and got everything in order. So that's what I'm going to do right now. The first column I use in the table is the original data value. So originally I had a 1, a 2, a 2, a 2, a 4, a 4, a 4, and a 5. Secondly, I'm going to be comparing each of these to the mean. Well, the average that we just calculated was a 3, and it's a 3 for everything. The mean of the data set is 3. All right, and now deviation, aka distance. We're going to be finding how far is each number from the mean. That's super, super simple. How far is 1 from 3? It's 2 spaces away. How far is 2 from 3? It's 1 space away. 2 from 3, 1 space. How far is 2 from 3? 1 space. How far is 4 from 3? 1 space. 4 from 3, 1 space. How far is 4 from 3? 1 space. And how far is 5 from 3? It's 2 spaces away. You'll notice that I don't have any negative numbers there. It doesn't matter if it's above or below the mean. We're just measuring the distance, and we're not talking about negatives here. So it's always going to be a positive distance. Anyways, now I've got pretty much all I need to do this. I've found the deviations. I found the distance from the mean. And the last step is we are going to find the average distance, aka the mean of the deviations. I wrote that as the step. We are going to find the mean, the average of this column right here. And how do you find a mean? How do you find an average? You add all of the numbers up and divide by the number of pieces of data. So I'm going to add 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 and divide by 8 since there are 8 numbers there. So let's find the mean of the deviations. 2 plus 1 plus 1 plus 1 plus 1 plus 1. Do I have enough? Plus 1 plus 2. I think that's all 8 values, and we're going to divide by 8. 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 is equal to 10. And when you divide 10 by 8, you get 1 1/4, 1.25. So we're done. We have found the MAD. This tells us that on average, a number in this set of data is about 1.25 spaces away from the mean. And what that tells me is, since the mean absolute deviation, since the distances from the mean are all pretty small, that means that this data set probably is not very spread out. Everything's pretty close together. Everything's within about 1.25 spaces of the mean. So like the mean is a measure of center, and everything's within about 1 1/4 spaces from the center. That's a pretty close together set of data. Remember, this is a measure of variation. This is not very varied. It's pretty close together. Some of you might be saying, like, what the heck? Why would you even do this? How is this valuable? Well, I've got something for you. What you see on the screen right now is the data for 2 different pitchers, baseball pitchers. Pitcher A, this is 10 different games, and pitcher A in his first game, he let up 4 runs. In the next game, he let up 6 runs. In the next game, he let up 6 runs. In the 4th game, he didn't let up any runs, and so on and so forth. And then you can see the data for a separate pitcher. Pitcher B, we'll call this person. This pitcher let up 6 runs, 4 runs, 4 runs, 5-0, and so on and so forth. Now, let's say it's close to the trade deadline and you're a team that needs to pick up a pitcher. You're going to trade for a pitcher. So you're monitoring these 2 guys. There are 2 guys you've got your eye on. Who should you pick up at the trade deadline? Which one's a better target? Well, the first thing you might look at, if you're in the data department of the baseball team that's looking to make the trade, you might say, well, what's the average amount of runs that they've allowed over the last 10 games? Well, if you sat there and found the average, you'd find that pitcher A, on average, has let up 3.5 runs per game. And you'd find that pitcher B has also let up 3.5 runs per game. I didn't show the math, but all I did was I added up all of the runs and divided by 10. And both of them happen to have the same exact average. So the mean doesn't actually help me right now. They both have let up the same number of runs. I need something to help me better distinguish these 2 pitchers. How do I know which one's better than the other? What's another measure that could help me? Well, the mean absolute deviation is going to tell me which person has less variation, which person is more consistent. So I also went ahead and calculated the MAD for each pitcher, and what I found was that pitcher A had a MAD of 2.4, whereas pitcher B had a MAD of 1.4. And since the pitcher B had a lower MAD. That indicates to me that pitcher B has less variation, aka pitcher B is a little more consistent. Yeah, he lets up an average of 3.5 runs per game, but you pretty much know what you're getting. He's not going to be all over the place. He's not going to have games where he lets up 0 and then 8 runs and then whatever. He's much more consistent. You know what you're getting, and that might be something that helps a team decide who they want to get. There's less variation to that guy's data, so maybe he's a more consistent pitcher, and maybe that's what you want for your team. Either way, MAD measures variability, variation in data, and we've gone over how to do it. That's what you're going to be practicing today. You might need to refer back to this, but just go through the steps, right? Step 1, you're finding the mean. Step 2, the distance from each point from the mean. And then lastly, those distances that you found, you're just finding another mean, adding them up and dividing by the number of data points. You can do that. It might take a little bit of practice, but I'm confident you can do it. Have fun, as always. Mathematics, woohoo! See ya.